Hi everybody, this is Miss Bame. Today we are going to be talking about concentration and how to calculate it. Before that, I want you to go into Schoology and make sure you have downloaded the concentration practice PDF from our Schoology folder. And it's going to look like this right here. So our agenda for today, after you download that, so you might want to pause this video and do that, is to review the different types of concentration, and then you will be doing those practice problems at the end of the lesson. And the goal for today is you will be able to calculate concentration in 3 ways: molarity, ppm, and percent volume. There are lots of different ways to measure concentration, but for our purposes in this class, we'll be talking about molarity, parts per million, and percent by volume. I want to do a quick review from last class of what concentration is, and it is the amount of a particular substance in a given quality of a mixture or solution. This picture on the left here is an example of how we have barely concentrated. Let's use a real marker there. Okay, so something that is very dilute, not concentrated, and then at the end here we have something that is very concentrated. And the vocab words you should be familiar with is solute, which is what you are dissolving, right here. Solvent, which is what is doing the dissolving. That's usually going to be water, so in this case it's the water here. And then the solution is the mixture of everything together. First one is molarity. Molarity is what you're going to see the most when we are talking about concentration. It is what chemists use the most to describe how concentrated something they're working with is. And it's usually measured here by the moles of solute that's in the solution divided by the liters of the total solution. And you will often see it abbreviated as just moles per liter there. So kind of shorthand there, that's what you'll typically be seeing. And so this image right here on the left, bottom left, it is 2.0 m HCl. So that means there are 2 moles of hydrochloric acid in each liter of this solution. And then on the right here, we have a 0.1 molarity of sodium phosphate, and that is telling us that because it is the 0.1 molarity here, there are 0.1 moles of sodium phosphate per liter of this solution. So if I were to write out, we'd have 0.1 moles per 1 liter, and that's going to give us 0.1 m, and we are going to do a lot more of those calculations next. Let's do our first problem together, and this is going to be the first question on that concentration practice PDF that you should have downloaded to Notability. And the question is stating, if I place 2.5 moles of C12H22O12, also known as lactobionic acid, in 1.5 liters of water, what is the molarity? So just like always, let's identify our variables. So first I'm going to highlight them. So we have 2.5 moles, we have 1.5 liters, and then it's asking for the molarity. So we do not know that. So the molarity, let's just put a question mark here. The volume is 1.5 liters, and the moles of the solute is 2.5 moles. And the second step is to find the right equation. I've already written it here for you. This is the equation you will use with all of the molarity questions, but you might have to reorganize it in order to solve for different things. In this case, we are solving for molarity, so we can leave that there. Then the last step is to plug in and solve. So I'm going to do the shorthand of it. So M equals, which is the same as molarity, moles of solute divided by liters solution. So we have 2.5 moles of our solute divided by 1.5 liters of our solution. And I have my calculator, 2.5 divided by 1.5, and I get 1.67 m. So the molarity of the solution is, let's make this a different color, 1.67 m. So make sure you have this written down for your concentration calculation worksheet. This question is very similar to the first one, but instead of solving for the molarity, we're going to be solving for the moles for this question. So first step, like always, let's list our variables. I'm going to highlight them again. So first thing, we're trying to figure out how many moles, so I'm going to highlight that. We have 4.0 liters of our solution and 0.75 molarity as our concentration. So listing our variables, I'm going to write down under molarity, we have 0.75 m. Our volume is 4.0 liters, and we do not know what the moles solute is. So our second step is to find the right equation. So we always start with the molarity equals moles of solute divided by liters of solution, and then we rearrange it. In order to do that, we would multiply the liters of solution on both sides of the equation, and that gives us this equation here. So the moles solute would be on its own, and then it would be molarity times liters of solution. And the next step is to plug in and solve. So I'm just going to write moles here. Our molarity we'll plug in is 0.75 m multiplied by the liters of solution, which is 4.0 liters. And then we use our calculators to solve. And we have 3. So we have 3 moles of this lactobionic acid. If you noticed, I labeled my answer there. Okay. Our second way to measure concentration in Principles of Chemistry is to calculate the parts per million of a solution. So what is parts per million? Otherwise known as ppm, which is how you'll see it abbreviated. So it is another way to measure concentration, but usually when there's barely any of the solute that we're trying to measure. So there's not going to be a lot there. And it measures the number of solute particles out of 1 million of the solution particles. So it makes sense, out of 1 million, so we got ppm, parts per million, and the equation for this would be the grams of the solute in the solution divided by the grams of the total solution. And then the second part, don't forget, is that you're going to multiply it by 1 million. And the reason that we do this is if the number is super small, this is a way to put it on a scale that is easier to recognize. So let's do our example problem for parts per million. This is the first question on your worksheet that you have downloaded under the second part. So parts per million, question number 1. Follow along with me as we go through this, please. So the question says, if I place 0.0025 grams of salt and 10,500 grams of solution, what is the ppm, or what is the parts per million? So first, what I'm going to do is identify the different variables that we have. So we've got grams of salt, which is our solute. I'm going to write that there. This is our grams of solution, and it's asking for the ppm. So our grams of solute is 0.0025 grams. Our grams of solution is 10,500 grams. And our ppm, we don't know. And now we have to find the right equation. This one I've already listed it. You will be given the 3 main equations at the top of your worksheet, like this one that you have. You might have to rearrange later like we did with our last question. But for this case, we're solving for ppm, so this equation works perfectly for us. Last step is to plug in and solve. So grams of solute, 0.0025 grams divided by 10,500 grams, and then don't forget to multiply by 1 million. And I'll get my calculator out and solve. Make sure you're using the right number of zeros, otherwise it can get messy fast. So for parts per million for this question, I have 0.238, and then I'll put the ppm there as well. That would be my answer for question 1. So you can see here we barely have any grams of our solute and we have a lot of solution. That is why we would use parts per million for this question. And now for our last and final way we're going to calculate concentration, which is percent by volume. So what is percent by volume? Otherwise abbreviated as just percent volume like that. It measures the percentage of the volume of the solute compared to the entire volume of the solution. So this equation here shows what I just explained. So on the top of this equation we have the volume of the solute, and then the bottom is the total volume, and then in order to make it percent volume, remember to multiply by 100. And these examples on the right here, for our high C, it says contains 10% fruit juice, so that would mean the volume of fruit juice is the volume of the solute, which would go on top, and then overall the entire solution is our high C, which would be on the bottom here. Then we would multiply it by 100. Same thing with our reduced fat milk. And let's do our last problem together here. So this is at the bottom third of your calculation practice worksheet, and this is for your percent by volume, question number 1 under there. So the question states, if I place 22.5 milliliters of salt and 175 milliliters of water, what is the percent volume? So first thing I want to do is go through here and identify my variables. So the salt here is our solute, and we have 22.5 milliliters of it. The 175 milliliters is of our solution. So I'm going to write that down. And it's asking us, what is the percent volume? And you don't always need to write out all the variables like this, but it is a great way when you're starting to learn how to do questions like these in order to organize your thoughts. So the volume of the solute here is 22.5 milliliters. The volume of the solution is 175 milliliters. And the percent volume, we don't know. Next step is to find the right equation. It's already listed here. Again, you might have to practice reorganizing this equation in order to solve maybe for a different variable, but in this case we are solving for the percent volume, so we can keep this equation as is. And then we plug in and solve. So the percent volume equals the volume of the solute, 22.5 milliliters divided by the total volume, and then we multiply that by 100. I'm going to take my calculator. I'm going to first solve for what is inside of those parentheses. That is how we won't have a lot of calculation errors. So I have 0.1286, let's go with. Then multiply that by 100. I'm going to keep writing down here in order to get the percent. So we have 12.86%. And that would be our answer for the percent volume of salt in this solution. Okay, so your next steps are to finish the rest of the questions in this concentration practice worksheet. We did together these ones. So go through and finish the rest of those questions, and then take the 14.2 quiz in Schoology.